Hello everyone, welcome to our Lien development and its impact on software testing webinar series. My name is Christine and I'll be your moderator. Today's webinar will be led by LogicGear's co-founder, Michael Hackett. Before we begin, let me cover a few housekeeping items. First, this webinar will last about 45 minutes. We will not have a Q&A. Instead, please DM any questions you have and we'll follow up with them after the webinar. This webinar will be recorded and distributed within 48 hours. Now, let me introduce Michael and LogicGear. About LogicGear. LogicGear is a leading provider of enterprise software testing solutions and test automation tools. Michael Hackett is a co-founder of LogicGear. In addition to software engineering work, Michael has provided training for Salesforce, Fidelity, Intuit, Adobe, Bank of America, and many other software producers. His training courses have brought Silicon Valley testing expertise to over 16 countries. Michael has 2 decades of experience with software engineering, quality assurance, and testing of various applications. Michael is a certified Scrum Master and holds a Bachelor of Science degree in Engineering from Carnegie Mellon University. In Part 1, Michael will cover the origins of Lien. Next, he'll explore the first 4 out of 7 principles, analyzing each principle's effect on testing and testing team culture. With that being said, I'm going to hand it over to Michael. Take it away, Michael.
Hi, everybody. My name is Michael Hackett, and today we're going to be talking about Lien software development, and particularly on its impact in software testing. So my theory here is that people develop software in same or similar traditional methods for a long time, and then seemed like everything changed in 2001 when the Agile Manifesto was written, and we've never been the same since. I think that a lot of the changes that happened in software development in the early 2000s, mid-2000s, were the impact of Lien software development, and we're going to take a look at Lien and dig down into software development life cycles the way they are today, and based on the impact of Lien. So what we're going to do today is we're going to talk about Lien and what Lien is and try and get a good understanding of Lien software development, particularly looking at the impact on Agile and the thinking behind DevOps. Understanding each of the Lien principles is really key to either just simply understanding Lien or having a Lien implementation or optimizing the practices that you have now, knowing the Lien principles. Also to look at particularly at Lien and quality, because Lien, I think, has had a tremendous impact on quality, and I think that in some organizations this has been the last piece to implement in being Lien. So let's Lien meaning like optimizing. You can optimize without focusing on quality. So we're going to be focusing more on quality. And of course, because this is mainly about testing, we're going to look at the impact of Lien on testing and on testing task distribution, particularly with more developer testing these days, people trying to be Lien in the sense of quicker, faster, distributing more tasks, more testing tasks to developers. We're going to look at how that can be implemented better, understanding the Lien principles. And along the way, we'll be talking about DevOps and the DevOps practices, because Lien has absolutely had a giant impact on even the beginning of what DevOps is. And we're also going to be focusing on some culture topics, because Lien is as much about culture as it is a set of practices. Lien isn't really a set of practices. Lien is a culture. So we're going to finish up by looking at some first steps that you can take if you want to be Lien, or you want to take whatever SDLC you have now and want to make it more Lien. We'll look at what some first steps are. So let's get started. Lien, I say the Lien has taken over software development. Lien has taken over the world, and the software development world. And I want to take a lower level look at that. But even I think that some people are doing some Lien practices without even knowing that they're Lien. For example, just-in-time. Just-in-time is probably the most common phrase that people use about Lien. Making just-in-time decisions is a foundation principle in lean software development. Kanban and Kanban boards or Scrum boards to visualize work in progress. That's lean. Faster or continuous flow of smaller releases, lean. The whole continuous delivery and DevOps thing comes from lean. And even particularly from a book, Lean Startup by Eric Ries, this idea of an MVP has taken over so many companies that this idea of releasing a minimum viable product or a minimum marketable product or a minimal functional product. There are a couple of varieties of this notion of MVP, but that some companies to base their whole development around MVP, and that is a direct lean idea. So let's take a look at where this all started. We know lean. Pretty much people know lean comes from lean manufacturing. It actually started as a Toyota production system a long time ago. Taiichi Ohno and Eiji Toyota did pioneering work in lean manufacturing. It started to be called lean in about 1988, even though a lot of the practices were developed back in the 40s. And where this really burst into software development was in 2003. Mary and Tom Poppendick wrote the book LSD, Lean Software Development and Agile Toolkit, taking the lean manufacturing principles and applying them directly to software development with software development examples, and great book. And if you're into reading books about software development, this is where you start. So from a very high level view, old style production lines were you made whatever you made. You made a car. And then at the end, when the car was finished, there'll be an inspector, and an inspector would do a quality control practice, go around with the clipboard and say, it does this, check, it does that, check, it does this, check. You would check it at the end that it met this criteria that you set out at the beginning. That's costly, and I hope just by me saying it, you know that doesn't work. It doesn't work to add quality at the end. You can't add quality at the end. It doesn't work to try and add quality at the end. Right? Modern production line is you find defects as fast as possible. So you don't wait till the end, till the car is finished to find a defect. You do one step and then you check to see if that's right. You want no defects to progress to the next phase. So when you complete one set of tasks or one chunk of that car, you check it and make sure that there's no defects there. You check it, you test it, you inspect it, you do those things, but at each step, you test it every step, so that by the time you get to the end, the product is finished. You're not saying, oh, we have to throw this out or send it back to the beginning of the line and fix this thing because it's done and we're finding the issue now. So I hope you all understand why that's wrong and costly and bad, and it's not how production works anymore. So this idea of lean and what is lean? Lean, I went to the dictionary and looked it up. Lacking or deficient in flesh, like lean meat. People are very understanding of that definition. But even that lean might mean lacking freshness, richness. I want to use this definition number 4, that lean is characterized by economy. Lean is characterized by economy, an economy of style, an economy of expression, an economy of operation. And that's really what production, making software is production line, right? That we have this economy of software development, and that's really what the meaning of lean is here. So the thing about lean is there's all these lean principles, and some are used, some are not used. Sometimes people pick and choose what they want to do. The key, the most valuable piece of lean is centered on preserving value, delivering value. Value is one of these words that a lot of people use in the Agile Scrum world of customer value, customer to value. So lean is focused on preserving value with less work, doing the minimum, like a minimum viable product, doing the minimum amount of development, the minimum amount of testing, doing the minimum, but retaining value. So it doesn't mean we just do the minimum. We have to preserve value. We have to maintain value, but with the least amount of work possible. So what we're going to spend most of today talking about is understanding these lean principles. So Lean is a set of principles adapted from this Toyota production system. So let's just jump right in. The 7 Lean principles. First, eliminate waste. If this is the only thing you remember out of this, or a week later, if somebody said, "What is Lean about?" you say, "Eliminate waste." You're more than halfway there. So Lean is about eliminating waste. It's also about amplified learning, decide as late as possible, like just-in-time decisions, deliver as fast as possible, empower the team, build integrity and equality at every step, and see the whole. So I got this version of the Lean principles from Wikipedia, where there is an Agile manifesto and there is a Scrum guide that define what Agile and Scrum are. People will state Lean in different ways for a variety of purposes. Whether someone says, instead of amplify learning, they say enhance learning, or create knowledge, empower the team, energize workers, respect people. There's different ways that people can express Lean. I'm going to stick with these words that I just used when I went over the Lean principles, but don't discount any of them, because they're not the exact words that are hanging on the wall in somebody's office of what Lean is. So first, eliminate waste. When I said that if you remember, this is the only thing you remember about Lean, you're halfway there. Lean is mainly about eliminating waste. When I first said the main focus of Lean in software development is retaining customer value. Customer value is expressed however you want to express customer value. How I would express it as quality, even like quality as in user satisfaction or good user experience, or software quality type idea, with the minimum amount of work. So eliminate waste is cut what's not needed. Stay focused. Run the essential. Don't do extra. This sounds great. Cutting waste sounds great. Everybody wants to cut waste, but this may give you some tough choices that may increase risk. For example, when I say run the essential, no extras, let's say an example that we're going to use a couple of times today, you have a full regression suite, and that full regression suite is 50,000 tests or 100,000 tests. They get run on an overnight build, or hopefully they're automated, and it doesn't take you a week to manually execute these, or it might even take you a week to execute 100,000 tests if you've got to run it across a variety of platforms. Even if they're automated, you may have to run it across multiple devices, browsers, character sets, whatever. How do you know to run the essential and no extras? When people talk about eliminating waste, when the Agile and Scrum revolution took over, the first thing everybody did was stop writing these big documents. No more design docs and architecture specs and engineering specs and user requirements, system requirements, and these just documents. Cut them, because there's a whole lot of waste there. Well, that's great. We'll be talking about a lot about documentation. How do you deal with that with your automated regression? If you have these 100,000 automated tests that you run a lot, and you're really reliant on them to show consistency, but you don't have time for a weekly regression anymore, to run these automated tests for a week or even for a full overnight, how do you cut? How do you only run the essential? If you're going to cut your 100,000 tests to 100,000 tests on 4 platforms to 25,000 tests total, this is going to require some tough choices and may increase risk. So it's not only pretty like, oh, let's stop writing design docs because they're a waste because we changed the design, and that's what Lean is about. No, Lean might be about you have these 100,000 automated regression tests that got old. There's duplicates. There's a high maintenance cost. Takes a long time to figure out why some of the tests failed. All of those things that happen in an automated testing suite. What are you going to do with that? Continuing to rerun those 100,000, there's probably a lot of waste there. So it may involve some tough choices and may increase risk. I have some discussion here about what waste is. Waste is like extra features. It's why we do a minimum viable product. Waste could be mismanagement of a backlog, or knowledge loss, like somebody leaves the team and you have to spend a whole bunch of time training people up, or trying to onboard people or ramp people up to speed. There's a waste there. Waiting, handoff are typically looked at as the biggest waste. Defects are a waste. So people write defects, not intentionally, but there's defects in software. The goal is to find them as fast as possible because they're a waste. Waiting till the end, that old style production line of you test at the end, that doesn't work because it's going to create a whole bunch of waste going back to the beginning. So examining waste and looking for places of waste, I have this whole big list that hopefully you can take a look at in greater detail and see what a couple of other people's opinions are of waste, is a key piece of implementing Lean, is looking for waste, not only waiting and handoff, but like multitasking and task switching. There's a waste to that. So finding waste is a key starting place to implement Lean. So looking for waste, cutting waste. But now I want to throw something out about testing. Remember, there's a piece of testing that is by nature somewhat redundant. Right? I could run a test. We change something in the software. I need to run that same test again. And some people may think of that as redundant. When I said earlier, I gave an example that I have 50,000 tests, and I'm going to run them across 4 platforms and across a couple of different browsers, across a couple of different mobile devices, and a couple of different character sets. There's going to wind up being a whole lot of redundancy there in some people's mind. Now, to me, I could say running a test on Chrome or Firefox is very different than running that same test or doing that same task against Safari, or doing it against one character set of the QQ browser that's showing double byte characters. It's a very different test to me, except that I'm running the same exact test. I'm just running it against a different browser. So to bring this down to a finer tooth comb, I have the same test, but if I switch environments, I'm running against a different browser. To me, it's not the same test anymore. It's a different test. I changed the character set. That's now a different test. So you have to be careful when we say look for waste, or when I say that there's this Lean practice of look for waste and cut waste. Some parts of testing are looked at as redundant. And you can't just cut tests because you feel like cutting a number or cutting time. You have to be thoughtful about this, and it may increase risk. Okay. So one thing that I want to start thinking about testing differently in this Lean conversation is this Lean principle of amplified learning. We're going to talk about amplified learning later, but I want to just put it out right here. Testing is amplified learning. When we run tests, we are learning about the system, right? So we have this chunk of a system that's built. We're learning about it by testing it. How's it going to work under this condition? How is it going to work on that condition? How's it going to work with this piece of data on that browser? How's it going to work with that same piece of data on a browser for double byte characters? How is this system going to work with that piece of data on Safari? How is it going to work on this other configuration? We're learning about the application. So testing is amplifying learning, right? We're learning about the application. So this idea of testing as a seemingly, to some people, redundant process needs to be balanced with testing is learning. And Lean is all about learning. Lean is all about learning. Learning and growing, improving processes, optimizing the code, optimizing the system by learning, through learning. Next thing about waste, let's think about automation. I brought up this idea of automation with cutting waste just a couple minutes ago. But even when we're writing automation for the first time, not rerunning a big regression suite that we may have inherited and now we're going to try and be lean, but automating only what's worth automating. Automating important tests, not automating every test, not automating happy path tests, not automating for the sake of automating. Automating because it's a meaningful test, it's a useful test. Mundane or repetitive tests, we know run manually is a waste, but even automated, all the time to write the test, run the test, and then maintain the test, right? There's going to be waste there. So we're going to talk about automation strategy later on to not even introduce waste from the start, automate important tests. Don't automate every test, just automate important tests. So to pull this piece about waste together, looking for waste and cutting waste is not as simple as some people think. It needs to be done thoughtfully and intelligently, because it could introduce more risk. It will introduce more risk. I want to bring up one more thing about this waste, like multitasking or handoff and waiting. A lot of companies have moved to the idea of getting faster and releasing faster by having developers take on more testing tasks and having cross-functional developers who also test. Sometimes people call them hybrid. They're in a hybrid role of developing and testing. To minimize waiting and handoff from the old idea that we have developers write code, and what do testers do? They wait, they write a bunch of test cases, but they're waiting. They get code, and then testers test like crazy, and what do developers do? Wait for bugs, wait for bugs, wait for bugs. There's handoff and waiting going on here that is not a good idea in Lean. It's a waste. So let's cut all that out, and let's have developers, and they write code, and then they test the code. It minimizes this handoff and waiting, and which sounds great. It sounds great in its idea, but we know that developer skills, developer mindset is very different than tester skills and tester mindset. That's not the purpose of today's talk, but I've actually done other webinars and have written a bunch on developer mindset, tester skills, developer skills, and how to do this, how to think about this distribution of tasks to be more efficient. We can be more efficient, but shifting all of the testing tasks to developers has to be thoughtfully done, and it has to be done with the right culture, the right skill sets, the right allocation of time. It's more complicated than just, hey, run a unit test to validate this acceptance criteria, and now you're done. You don't have to test anymore. So I want to bring up another idea, another unique idea in this waste thing, and that is writing plans. I say plans here in a more generic way, but I'm really thinking about test plans because we're focused more on testing in this webinar. But Mary Poppendick, who wrote with her husband the Lean Software Development book, has this great quote from her website. Predictable organizations do not guess about the future and call it a plan. They develop a capacity to learn quickly and rapidly respond to the future as it unfolds. It's a beautiful idea. Predictable organizations don't write a test plan or write a development plan at the beginning of a project and then, oh, shoot, we can't do it that way. That's not how it turned out. They develop the capacity to change and to learn quickly. Learning leans, right? We learn a couple of things, change our plan. Learn a couple more things, change our plans. And to rapidly respond to that as it unfolds. This is a beautiful idea. So the idea of a traditional test plan, let me say that. The idea of a traditional test plan, I think, has to go out the window. I think any kind of test plan we write now has to be lean and mean. It has to be just about risks, just about roles and responsibilities, like you're doing this, I'm doing this. It's not in the old days, people would write these big test plans that were giant, based on the IEEE standard for, if you need regulatory compliance or something. And you can use that as a template. You can use that IEEE 829 standard as a template. But remember, template means you keep the sections that are important to you and you get rid of the others. So I'm not against writing test plans. I think you can be lean and write a lean and mean test plan. So the traditional, the old style test plans may be out the window, but it doesn't mean that we're going to stop planning or stop strategizing at all. So this idea that sometimes people think eliminating waste means stop documenting it all, that's really extreme. And Lean doesn't say that all documentation is a waste. Right? We're gonna talk about that. Just because something is written doesn't make it overhead. There's a whole lot of important stuff that can be written about a product or about a development practice or a system that's not overhead, that's essential to the product. So Lean doesn't mean no documentation. It means lean documentation, lean and mean. So I want to illustrate this by thinking about milk for a minute. You know milk, right? Everybody knows milk. We have whole milk, and we have reduced fat milk, and low fat milk, and we have skim milk. Whole milk actually has about 4% fat in it. Reduced fat, 2%, low fat milk, 1%, and then non-fat or skim milk, right? Some people think that lean means you go from 4% to non-fat. You get rid of everything. Get rid of everything. No fat at all. Well, as we know, some people don't like the taste of blue milk, of non-fat milk. Might taste terrible for what you want to eat, and it's not gonna satisfy anybody by switching from whole milk to non-fat milk. So you can cut fat without going to zero, right? So we can lean looks at getting rid of waste where there's waste. It doesn't mean stop doing practices or documents or needed tasks that are crucial for customer satisfaction to run smoothly. It's examine what you have, cut the fat. Examine what you have, cut the extra. Only do the essential that you need to release a quality product, right? So going from a fully documented product, an over-documented product, to stop documenting it all, that's probably going to be a mistake. So, and I don't even mean to focus only on documentation. It could be practices, just as much as it is documentation. But lean and this idea of cutting waste needs to be thoughtfully implemented. What one common idea about lean, particularly with documentation, is if it doesn't go to the customer, it's overhead and a waste. But think about test cases, right? Test cases have never been intended to go to customers, or rarely go to customers. And it's a byproduct rather than the product itself. And Lean has this idea that if it is a byproduct rather than the product, it's a waste. But some repetitive tests, some documentation is needed. You just want to minimize it. How can you share tests with another team, or use test cases as a way for people to learn the product or ramp up on the product or replace people? Some people leave, and to get new people in who are going to be doing some testing tasks, or even to have a regression suite or to more accurately reproduce something, you're going to need some amount of documented test cases, right? So we can't just completely stop documenting. We just want to be lean and mean and document the minimum. All right. Eliminating waste is the big overriding principle in Lean, and now I want to go look at the next three together. Decide as late as possible, just in time, deliver as fast as possible, and build integrity and quality at every step. So just in time, you've probably heard of just in time and what just in time is about. It's probably the most famous next to cut waste as far as Lean practices. What it means is just do the next thing in front of you. You don't have to plan out what the whole project is going to be like. The quote that I gave of Mary Poppendix earlier, a successful organization doesn't try and even plan out how the whole project is going to go. You can do the next thing in front of you and learn and adapt quickly as the project unfolds. Don't make decisions on things that may not happen. The biggest example people use with this just-in-time idea is, in the past, people would write, for example, a design doc. They'd have somebody would write a design document, and you would do a design review, and then people would sign off on the design. Let's say it's February, and you do this design doc, and you have this design review, and everybody signs it off. Great. Well, it's going to take a while to implement this product, and it could just be even a month later. Later on in March, it comes time to write this chunk of code, and we look and think, oh, I can't actually do it the way the design says, because this third-party component is different, or this the OS has this limitation, or now that we've built this last chunk of the product, now I can't build this the way that we thought we were going to, and now we have to change the design. Are you ever going to go back and re-baseline the design doc and go through that whole reapproval process? No. What are you going to do? You're probably just going to make a change, and the design doc that we just wrote a month ago is out of date and essentially useless. So that may sound extreme, but some of you, I'm sure, could identify with this. So when is the best time to design that function, that thing that I have to write? When is the best time to do it? When I need it, right now. It's writing the code for this function is the next thing for me to do. Now I'm going to design it. Great, sounds great. It's the most economical. It's going to cut that whole idea of writing this big document and now making a change and all that. I'm just going to write it right now. Great. Well, easier said than done, right? I can't write my function that maybe even the way that I think is the best right now if it's going to break 5 other things. Or if it's going to break one other thing, I might not be able to write it the way that I want it. I can't just be, and most of us work on complicated integrated systems. I can't just design in a bubble. I can't just design on my own by myself and break other things, right? We'll get to that piece. So people, you get this idea of what just-in-time is. I want to add something else. I want to add just-in-time test design. Just-in-time test design is a very powerful approach to testing. Let's call it exploratory testing. We can call it ad hoc testing. We're not going to have a discussion about what exploratory and ad hoc is in a low-level detail. Most of you who are listening to this probably know what exploratory and ad hoc testing is about. But just-in-time test design. So I could have gotten this design doc, and I could have started to write test cases, right? And said, okay, if this is how it's going to be designed, I want to test it this way and test it this way, and started to test cases. Now I get the actual function. I get the thing. And what happens? It wasn't implemented the way I thought, or it looks different, or how they said they were going to write it, even if they wrote it that way, it may behave differently. Maybe the test cases that I wrote that I spent all that time detailing need maintenance already, and I haven't run them once. In some cases, some people tell me that they have to throw those test cases away because it's not what the system looks like. The best time for me to design tests is just in time. Right now I have a function, design tests. If we are skilled and we're trained and we know what the product is supposed to do and we know who the users are and we're knowledgeable people, we get this function, we can design tests. We're not going to pre-document them. We're not going to heavily pre-document them. I might write when we in reality, if we have a sprint planning meeting, we say, here's a user story. This is what the thing is going to do. And I'll know, even when we're sizing it, I might say, well, I want to test it this way. I want to test it that way. I want to test it this way. I can do like a high-level test objective. I can write, this is a test case title, or this is a test goal that I want to do, without writing step, or even validation points. But just-in-time test design is a very powerful way to approach testing because I'm testing it how it's actually built. And the whole idea of pre-documenting tests is a weight, it's overhead, it's there's a maintenance cost, and I may not have even executed them yet. So if I am going to do any pre-documentation at all, it's going to be lean and mean, high level, one-liners. Just this is the title. This is the thing I'm going to test for. This is the item I'm going to do. This is the task I'm going to test. But high level, lean and mean, and do just-in-time test design. So just in time, you know what just in time is about. Next, deliver as fast as possible. Why do you want to deliver as fast as possible? To get immediate feedback, right? I want to get it into people's hands, get it into either the customer's hands or get it into the next team's hands as fast as possible to get immediate feedback. This is that whole idea of MVP that we all know about, and continuous delivery and continuous deployment, right? Do one thing and push that along the line. Get it to the next place. Deliver that function as fast as you can to get immediate feedback. It worked or it didn't work. It's what I want. It's buggy. It's good. It has slow performance. It's got good performance. I want to get feedback right away, as fast as I can. So you get the idea of what deliver as fast as possible is, right? You want to get immediate feedback, whatever that looks like. Now I want to bring up this idea again of, for example, it taking 5 days to run my automated regression. That's not immediate feedback. That's not delivering as fast as possible. If we want to fail fast, I think a lot of people know what fail fast is. Do something and then find out, did it work or did it not work? And if it failed, I want to fail fast. Whether that's a practice that I want to try a practice, and if the practice works, keep going. If the practice doesn't really work, it's not what we want it to be, fail it, change it, fix it, or get rid of it. So when I think about testing and when it comes to deliver as fast as possible, I want to think about deliver my test results as fast as possible. So to pick up on that idea I've said a few times, running 100,000 tests on how many different browsers, on how many different character sets, and how many different mobile devices, we could have if we had a really good cup of coffee, we could have a nice argument about how useful that is. But we should also talk about how useful it would be for the team if I could get immediate feedback back to the team. This works, it's slow, it's kludgy, we need to fix the UI, doesn't work with the next feature, whatever that result is, or bug, we want to deliver our results as fast as possible. So where I'm going with this is when we talk about automation strategy later on, this idea of more may not be where we want to go. If we have no automation, if you read this Lean software development book, it's great because it contrasts traditional development with where development should be. This has changed a little bit because we're doing this webinar now. It's 2021. A lot of organizations have been doing Agile for 15 years. People who are working on the teams don't even know what traditional development looks like. They hear waterfall as some dirty word. They don't even know how the projects went. So fine. The idea of having a full manual regression for a complex system is unheard of to teams like that. You have a lot of automation, but they may have inherited, or the team that's working on it now. Let's say that my team started using, Selenium, for example, great tool, great automation tool, started being rolled out big in 2018. That's 2008. That's 12 years ago. So some teams have been using Selenium for 12 years and have lots and lots and lots and thousands and 10,000s and hundreds of thousands of automated tests in Selenium because they automated everything. Well, this idea of trying to do continuous delivery or even continuous deployment with hundreds of thousands of tests that have to get run across a spread of devices and browsers is not delivering results as fast as possible. Right? We have to change this notion of automation from more automation to lean and mean automation. Just do the essential. Cut waste. We need to deliver our test results as fast as possible. All right, even thinking about some teams who do continuous delivery do multiple builds a day. Well, what are you going to test against each build? Hopefully you have a smoke test, a sanity test, a smoke test, a small set of tests that's going to say we have a good build or we don't have a good build, and not need to run your full regression. But this is trying to have a lean and mean set of tests, like a smoke test, that can say, yes, this is a good build. We're just doing what's essential, keep the value of our smoke test, and just run what has to be run, right? So deliver as fast as possible, deliver product as fast as possible, but also deliver our test results as fast as possible. Okay, and the next big idea that we could talk about for as long as you want to is quality at every step. Build integrity and quality at every step. Brings up this idea of who owns quality. We know from the Agile manifesto, from the Agile movement, from Scrum, from Lean, the modern development thinking is everybody owns quality. Everybody owns quality, and quality has to happen at every step. Quality doesn't belong to a QA team. From the old waterfall days in 1995, we had some QA team testing at the end. As great as they could be, as skilled as they could be, testing after development is completed is too late. And you can't add quality at the end. We know that's gone. So where do we get quality? We get quality from the start. We need quality at every step. We need quality user stories. If you don't have quality user stories, you're not going to wind up with a good product. So quality user stories, quality code, quality unit tests. But I've had discussions with a lot of development teams about writing either throwaway unit tests or garbage unit tests. If they have some kind of unit test coverage number they have to hit, they might just write a bunch of unit tests just to get high coverage numbers. But the unit tests, if there's bugs, the unit test suite may not find them. So we need quality unit tests. We need quality environments. You could have great automation, and if you don't have quality environments, your results are compromised. You could have a great automation, and if you're not using great data, your results could be compromised. So quality environments, have quality test cases, have good test cases. I just said data. You need quality automation, good bug reports, complete bug reports, reproducible when they are, details on them when they're not reproducible, quality test plans. So obviously you can't add quality at the end. You have quality at every step. And to me, focused on quality and focused on testing, this is the most important part of Lean. To me, way more important than eliminating waste is having quality from the start, building quality into the product instead of hoping or guessing that somebody can test it at the end and add quality at the end, which we've known for a long time doesn't work, right? We need quality at every step. And quality at every step has a special meaning in this CI/CD world. CI, continuous integration, and continuous delivery. Do something small and test it. Change a chunk of code, pull a build, run a build test, run a smoke test, and see that it works. It's do one thing and test it. Instead of bunching together a whole stack of changes and then doing a big build with lots of changes that if something breaks, it's hard to analyze and decipher. It's slow. The testing could be complicated. Something could have failed for 5 reasons. Versus you do one thing, test it. Do another thing, test it. Integrate a piece of code, test it. Move it to another environment, test it. Do one thing and test it. There's no big block of testing at the end, right? It's also important to do this when I say do one thing and test it, move it to another environment, test it, to think in terms of what kind of regression test you might run or what kind of tests you would run. If I change one piece of code, fine, what test do I have to run? Do I have to run my full regression? Can I run a smoke test? I'm not going to tell you what to do. These are going to be individual conversations with your team about risk, about what your plan is, what your strategy is for testing. But these are not inconsequential. These aren't throwaway decisions. If I move something from one environment to another environment, what do I have to test? We know we have to test something, right? What do I have to test? Just the thing that changed. Well, we also know that if I change one thing, it might break something over here. How much do you test? That being said, the idea of every time we do something, running a full, like even an overnight regression, just isn't going to work. It's not going to work. That's too much overhead. Just it would prevent me from wanting to make some changes in the code if every time I made some changes, I had to wait a full day to find out if it worked. So do one thing and test it. I think another way to look at this, continuous testing is a phrase people use with this, but even continuous delivery, continuous testing, write some code, test it. Do a build, test it. Package it, test it. Release it, test it. Configure it, test it. Monitor it, test it. Is everything we do, test it at each step. And when something breaks, you know why. You have a better idea of why it breaks. So most people would say when you do one thing and you test it and it's broken, you know why it's broken. Well, the skeptical nature I have as a long-time test engineer is do one thing and test it, and you have a good idea of why it may have broken. You don't always know, right? But do one thing and test it. One step and test it. People even say do something small. Do something small and test it. That way you do have a better idea of if something does break, why it broke, and you get immediate feedback, fail fast. I want to talk about culture with this quality at every step, because there really is a culture change that has to happen. If your quality at every step sounds like a great idea. Who doesn't want better user stories? Who doesn't want good environments, quality environments? Who doesn't want quality data every time we run a set of tests? It's great. There's no reason to not like it. But there's cultural things that need to change behind that. For example, there's no QA, there's no quality assurance team or silo that is the police or it's going to point fingers about quality. The whole team has to be enrolled in quality, from the PO who's originally writing user stories through the IT or the ops team who's building environments, either building environments for you or helping you build, supporting you to build environments. There's quality across teams, not only this one silo called QA. Everyone has a part in quality, and everybody tests. Release management tests, build engineering tests, ops tests, developers test, of course, POs test, testers test, right? We don't want testing heroes. That's not the way modern development is. It's certainly not the way Lean is, where there's testing heroes and there's no quality gatekeeper, right? Everybody has a piece in the quality puzzle. But how you distribute these tasks, it needs to be done thoughtfully, with adequate time, with adequate skill, with expert level skill, right? Lean about learning and amplifying learning, seeing the whole picture, good skills to distribute the tasks. So quality at every step. Specific to development culture, when you think about developer testing and distributing these tasks, what tests are best in the hands of developers? What tests are best in the hands of test engineers? For organizations who've moved much or most of the testing to developers, it's great to do functional testing, right? Great to do a lot of unit testing, even if I have to do testing through a UI or test an API service. I can narrowly test that. Developers can do that maybe faster than me. Good for them. That's great. But what about that idea of testing against multiple character sets, testing against multiple browsers, testing on multiple handsets, on multiple mobile devices? Do you really want to be using your developers to be testing across mobile devices or automating across mobile devices? Who different mobile devices have different sets of tools, and I'm going to be maintaining multiple sets of automated tests because different devices have to be automated differently. Is that really what you want your developers to do? When I started testing, one of my main jobs that was instilled on me by my first manager was my job is to be a customer advocate. When I test, I'm an advocate for the customer. If I'm validating functions, that's one thing, but who's going to test the customer experience? A UX team? A PO? Fine. How are we going to distribute those tasks? Because in a lot of organizations, it's still a testing team that does that kind of a customer workflow, even if it's not like user experience, like how easy is it to use. Let's say it's a workflow that I have to have even deeper technical knowledge, but I'm going to test this workflow from the beginning of the workflow, beginning of the transaction, all the way through the end of the transaction. That has to be tested because that's what your customers do, that's what your users do, and that's how you find integration bugs. Those kind of issues are not going to be found at the unit level, right? Somebody's going to have to do big, complicated tests like that that are harder to write, harder to execute and analyze and maintain, all those pieces that make it harder. Do you really want your developers, do they have the skill to do that? Do they have the time to do that? Rather than testers who that's main test engineering skills is being able to write and run those types of complex workflow, complex end-to-end tests, scenario tests. Are they best suited to do that? So when I say distributing these tasks has to be done thoughtfully, it's more than just we test the function and we're done. Or we've automated this acceptance criteria test on this function and we're done. Testing is a whole lot more complicated than that, right? Quality at every step, thinking in terms of culture, is you want to find bugs as early as you can. You want to do smart automation and not just automate every test you can think of, right? Remember, with automation, the biggest cost is always going to be maintenance, always. And who owns the maintenance? Creating tests, if you have technical testers, developers, even the tools are so much simpler today, and no code or low code automation tools, you can automate a whole lot of tests. But it's maintenance that's going to kill. Maintenance kills. And who's going to own the maintenance? Do I really want my developers managing the maintenance of the automated suite? Maybe they can run them. Maybe I can have an orchestration, pipeline orchestration tool that's going to take this suite that I have and it can call it and run the whole thing and get a result back and promote it to the next environment if that's possible. It's great. The CD tools are really amazing these days. But the biggest cost is going to be maintaining that automation, making it meaningful, changing it when it has to be changed. And do you want your developers focused on maintaining automated tests, or do you want them focused on maintaining production code or writing production code? So not as easy as some people think, this new distribution of tests. And as always, because what I do, does the team who's going to be doing the test, do they have the skills to do it? I mean, testers are trained. If you wind up in testing, you're going to have to do whatever kind of training you get or skills you get, books you read, however you learn, or just experience, hands-on experience, learning about testing. That's not the primary focus of developers. And do the developers, but I don't want it to be the primary focus. I want them, even when they do TDD, test-driven development is a whole separate, that XP, extreme programming practice, is not about test-driven development. We're not going to get into that. It's its own practice. And the testing there is unique to TDD. Do my developers have the skills to do exploratory testing? Do my developers have the skills to model good end-to-end tests? Do I want them spending their time doing that? So this culture, this mindset, and time, but also the skills. If we're going to redistribute the testing tasks, it has to be done thoughtfully.
Thank you for attending our webinar. If this sounds like something you're interested in, please contact us. Part 2 will debut at the same time next week. As a reminder, we will be sending out a recorded version of the webinar within 48 hours. Thank you for your time. Goodbye.